Welcome to our series on sharing examination style questions with you. Here is solution of another interesting question based on circles and tangents. I hope you will understand and appreciate the strategies involved in solving such a problem. In case you want to learn from me, you can always send an email on the address given. Now, let us enjoy the journey of success. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up solution of our question number 2 from the set of 3 questions. Well, the question number 2 is right in front of you. You can pause the video, answer the question, and then look into my suggestions. These questions are based on equation of circles, and we have added the complexity with tangents. You see such questions in test papers commonly. In case you want to learn from me, you can always send an email on the address given. In the earlier video, we had the solution of this particular question, the question number 1, correct? And then in the next video, we are going to take question number 3, which is right there on your screen. These 3 questions give you a lot of concepts about similar examination style problems on circles and tangents. Now let's look into question number 2 in more details. A line y equals to 1 over 3x is tangent to the circle C at point P with center at M, 7, 4. Find equation of the line PM. Find equation of the circle C. A line y equals to 1 over 3x plus k is also tangent to the curve. Find the value of k. So these are 3 different parts which we need to answer. For solving any question related to circles specifically, it is very important to visualize what we are working on. So let's read the question and try to understand the concept. We have a line whose slope is 1 over 3 and it goes through the origin, right? 1 over 3x is tangent to the circle at a point P with center 7, 4. So center is at 7, 4. So let's make a circle. Let us say we have a circle which is kind of like this. Now this is a circle with the center at 7, 4 and a line which is 1 over 3x, y equals to 1 over 3x is tangent to it, kind of like this, right? And of course, this will go through the origin. You get the idea. So we have a visual picture of what exactly we are talking about. That helps. That helps. So now it says the tangent to the circle C at point P. So this is the point P we are talking about with the center M that is given to us as 7, 4. Now we need to find equation of the line P to M. So if I connect P to M, then that line we have to find equation of. You get the idea. Now, P to M is the radius, right? And therefore, it has to be at right angles. Right angles means that the slope of PM will be negative reciprocal of the slope of the line given to us, correct? So that gives you the concept. So we have y equals to 1 over 3x, where the slope is, or the gradient is 1 over 3. And therefore, the gradient of line PM should be what? It should be negative 3, right? Negative reciprocal. And it goes through the point 7, 4. So it goes through the center of the circle, which is 7, 4. Now with this information, we can get the equation of the line PM, right? So at this stage, I would like you to pause the video, find the equation of the line PM. So let's work on the equation of line PM. Okay, so we can say that the line which is perpendicular to 1 over 3x will have a slope of minus 3. So we can write this equation as y equals to minus 3x plus y-intercept b. To find the y-intercept, I'll substitute the center of the circle, which is 7, 4. So it's going through the midpoint M, which is 7, 4. So 4 is the y value, x value is 7. So minus 3 times 7 plus b, and bringing it to this side, we get 4 plus 21 equals to b, which is 25. And therefore, we get the equation as y equals to minus 3x plus 25. Is that clear to you? So we got the solution of the first one, which is y equals to minus 3x plus 25. So I hope you find that simple. You must have got the same answer, right? Now, once we have this equation, we need to figure out the equation of the circle. How do we do that part? Okay, so we know now the equation of perpendicular line is minus 3x plus 25. Let's continue with this. So here is our diagram. We got this equation as y equals to minus 3x plus 25, correct? So that's the diagram which we had been working on. And we are saying that the line which is perpendicular and goes through the center can be shown as shown here, right? Right. So basically, if I know a point on the circle, I already know the center, which is at 7, 4, right? Then I can easily find out the radius, and therefore the circle also, equation of the circle. Okay, so this is intersection of the two lines, right? So it is intersection of two lines. And the two lines are y equals to 1 over 3x and y equals to minus 3x plus 25. So let's equate these two. So we get 1 over 3x equals to minus 3x plus 25. Multiplying by 3, we get x equals to minus 9x plus 75, right? Bringing it together, we get 10x equals to 75, and that gives you the x value. X is 75 over 10. You can work in decimals or in fractions as you wish, right? Now, okay, so let's simplify this, work in fractions for time being. If I divide by 5, what do I get? 5 times 15 is 75, and 5 times 2 is 10. So we get the x value. What is going to be the y value? Well, y value is 1/3 of x. So I can say 1/3 of 15 by 2, which is 5 by 2, correct? So we get this point P as the x coordinate being 15 by 2 or 7.5 and y coordinate being 5 by 2 or 2.5, right? So we get x and y coordinates for this particular case. You need to find the equation of the circle. To find the equation of the circle, let's find the distance, which becomes the radius, right? So you can find the radius, which is distance from M to P, right? Now that is equal to, let me find square of that, since in the equation we write r square. So that is equal to, you can say, the coordinate points 5 by, you can do the difference of these two, right? 7 minus 15 by 2, or you can say 7.5. Okay, let's write like this. Square plus 4 minus 5 by 2 square, right? So that is going to give us the radius. So you can calculate this and then find the radius. And that will give you the equation of the circle, more or less, right? So let's work this out. So let's do it on a fresh page. We got this point as 5 by 2, 15 by 2, and 5 by 2, right? So let's go to a fresh page. And to find we already find the equation of the line. Now let's find the equation of the circle. So what we have here is we have this circle with center, and we're trying to calculate. The center is 7, 4. And this point here is 15 by 2, 5 by 2, correct? A point on the circle. So we're trying to calculate this radius square, which is P to M square, which I'm saying is 7 minus 5 by 2 whole square plus 7 minus 15 by 2 and 4 minus 5 by 2 whole square, right? So that is what it is. So let's try to figure this out. How much do you get? So if I write this as 14, 7 times 2, so we get 14 minus 15 by 2 whole square plus 8 minus 5 by 2 whole square, correct? So that gives you half, that is half square is 4, right? 1 over 4. And this gives you 3, which is 3 square is 9, 9 over 4. Or we can say it is 10 over 4. So the square of the radius is 10 over 4. We know that the center M is given to us as 7 and 4. And radius square is 10 over 4. So therefore, now, can you write down the equation of the circle? Well, surely. So equation of the circle is what? Is x minus 7 whole square plus y minus 4 whole square equals to r square, which is 10 over 4. Correct? So we can write down the equation of the circle, which you know is written as x minus, let's say h and k are the centers. So it is y minus k whole square equals to r square. So this is the equation which we have used. And that gives us the answer, which is right there for you. Is that clear to you? So that is how we are going to do the part B. So the radius is 10 by 4, right? Now let's look into part C of this, which is a line y equals to 1 over 3x plus k also is also tangent to the circle. Find the value of k. Now, how are you going to do this? Let's try to visualize. We have seen the circle, and from here we found that one line was tangent. We want the equation of the other line. And in between, we figure out that we know these points, right? We know the center. Center is what? Center is 7, 4, right? That is point M. And we found this point P, which is 15 by 2 and 5 by 2, correct? From here, we can find the other end, Q, because M, the midpoint of the circle, is known to us, right? And you know these lengths are going to be equal, right? So that helps you to find the other end, Q, right? And we know the gradient will be same as 1 over 3, right? Since it is parallel to the given line. Okay, let's find the point Q. So let the point Q be AB, right? We don't know exactly, so let's write A and B. So now we'll use the midpoint formula. To find the answer for this. So midpoint formula is what? Well, the midpoint formula is that x1 plus x2, average value, is the midpoint, right? That is the midpoint formula. We know the midpoint, but we need to find the end point, right? So we can say that the midpoint is known, which is 7. So we can write here that the x value 7 should be equal to average of A and 15 by 2, right? So A plus 15 by 2 over 2. And similarly, we also know that the average of b and 5 by 2 is 4, right? So we know 4 is equal to average of b plus 5 by 2, right? So that should help us to find the answer. So let's cross multiply. We get 14 equals to a plus 15 by 2. So we know the value of a now. So a is equal to 14 minus 15 by 2, right? So which could be written as 28 minus 15 by 2, right? So that is the value of a. So what is that? So this is 13 by 2. Okay. So we get the value of a. Similarly, on the other side, we can work out the value of b. We get 8 equals to b plus 5 by 2. b is 8 minus 5 by 2, which is 16 minus 5 by 2, right? 8 times 2 is 16. And so the value of b is 16 minus 5 is 11 by 2, right? So we get the value of a and b. You get the idea. So we get the point q, which is basically 13 by 2, the x value, and 11 by 2 is the y value. So we get the point q. Now when you say that this line y equals to 1 over 3x plus k is also tangent, it has to be the other end, right? Because the gradient is same, correct? So with that, I hope you are in a position to find the solution, right? So can you work from here itself and get the answer? So we have the points on the system itself, and now let's try to figure out the equation. So let's go to the next page to find. So we found that the other point is known to us, which is we have the equation y equals to 1 over 3x plus k. To find the value of k, we'll use the point q, whose values we just calculated. What were the values? 13 by 2 and 11 by 2. So if I substitute these values for x and y, I should be in a position to find k. So let's do that. So we get 11 by 2 equals to 1/3 of 13 by 2, which is the value of k. So k is equal to 11 by 2 minus 13 over 6, right? So this is equal to what? 6 being the common denominator, 33 minus 13, which is 20 over 6. And therefore, we get our answer, which is y equals to 1 over 3x plus 20 over 6 as the other equation, which is tangent to the given circle. Perfect. So that is the equation drawn, as you can see, and the y-intercept being 20 by 6, right? So that is 20 by 6, the y-intercept, and the gradient is same as the gradient of the line given, which is 1/3. You get the idea. So that is how we can actually solve this particular question. So I hope you understand the complexities involved in this question itself, right? So we began with looking at the problem as a line which goes through the origin with slope of 1 over 3 is tangent to the circle, as shown here. So we sketched the diagram to understand the situation. Then, first step was to find the equation of line P to M, which is the radius or equation of a line perpendicular to the given line from the point of tangency, right? So, perpendicular slope will be negative reciprocal, and that helped us to find the equation of the line going through the center, whose points are given to us at 7 and 4, correct? And then we moved on and found the equation of the circle itself. That was possible because we know the center. We now figured out the point of intersection between the normal and the given line. So we had a point on the circle that gave us the radius with distance formula as shown here, right? And once you know the radius, then it was easy for us to find the equation. Perfect. Now that was the first part, part B, which we solved. Then it was to find the equation of the other line which could be tangent to the circle. For that, we found the point Q on the circle on the other side of PM, M being the midpoint. And that helped us to find the equation and the value of K. So I hope you find this interesting. Now, in the next video, we'll take up solution of this particular question. You can have a note and try. In case you need help on this, you can either contact me on email, address given here, or look into our video. That should help. Thanks a lot for your time. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. Thank you.